अच्छा बेटा, today is 9th February 2026 and it is our third class on wave or standing wave, and the question on the screen is October 2020, and in this question explain how nodes and antinodes are created on the string. This is the question. So to explain this question, I will have to explain the theory of standing wave. And what is the theory of standing wave? I am explaining and then we will write answer. The explanation is, consider this is a wave and this wave is traveling towards right hand side. And consider this is blue wave and having same wavelength, same frequency, same speed. Everything is same, but they are traveling in opposite direction and they are approaching. And as they are approaching, their amplitudes, consider they are 1 centimeter. Consider 1 centimeter. So everything in both waves is same. And now both waves are moving towards each other. And I can move this wave. Consider this is moving towards right hand side. This is moving towards right hand side. The blue wave also moving, which I cannot move. And now the two waves superposed upon each other. The two waves superposed upon each other. When the two waves superposed upon each other, then in this drawing you can see the crest of blue wave is passing over crest of red wave. In the same way, the trough of red wave is passing over or superposed over trough of blue waves. When the two waves superposed upon each other, then this way is called constructive interference. And due to this constructive interference, we have a principle of superposition of wave. And according to the principle of superposition of the wave, consider blue wave is 1 centimeter high, red wave is 1 centimeter high. So the resultant will be 2 centimeter high. Resultant will be 2 centimeter high, which I am drawing by black color. This black color wave is the resultant wave. When the two waves superposed upon each other, then their resultant wave is black wave. And the displacement of the black wave is equal to the sum of the two waves. And this interference is called constructive interference. Okay, so this is number one. And now I'm showing you number two situation. So the number two situation is, consider this is black wave, consider this is blue wave, and the two waves are moving towards each other. And consider I can move this wave. And when this wave move, and now the two waves are going to superpose upon each other. And consider both waves having same wavelength, which I could not draw. But now you can see the crest of black lie on the trough of blue. The trough of black lies on the crest of blue. Crest on trough. This is called destructive interference. This is called destructive interference. And in this destructive interference, this displacement is +1 and this displacement is -1. So their result is 0. So their result is 0. And for 0 resultant wave, this is the resultant wave. Consider the green color I am now selecting. It is the resultant wave. So you can see in situation number one, this is the resultant. And if you are a student of mathematics, then everyone knows this kind of graph is called sine wave. This graph is known as sine wave. And in situation number two, the resultant is a straight line. The resultant is a straight line. And now I am giving you the last situation. So in the last situation, consider, consider this is a blue wave. Consider this is a black wave. And the two waves again moving towards each other. And now I am moving this wave. And when this wave superposed upon each other, sir, it is again constructive interference. And in this constructive interference, this is the resultant wave. And now I am repeating, sir, the green is the resultant wave. So now you can see I have drawn three green waves. And these three green waves, the first one constructive interference, the second one is destructive interference, the third one is again constructive interference. And if you check, if you look, sine wave, straight wave, and reflection wave, it is called reflection wave. This is called sine wave, and this is the reflection of sine wave. And now you imagine, and I will share you an animation from YouTube in which the all three waves are shown in a very good way. You can understand how the way standing waves are formed. So if sine wave, straight line, and reflection wave, if these three waves are appearing in front of you, then it will look like this situation. This situation. Actually, this is number one, constructive interference. This is destructive interference, and this is again constructive interference. And due to fast movement of these three states, it appears loops are formed in the string. It is just like a fan. You know, a fan composed of three blades. There are only three blades in a fan. But when fan turns at a very high speed, then you cannot detect three separate blades of the fan. It looks like a cloud is moving. A cloud is moving. It is called persistence of vision, illusion. It is not real. There is no cloud. When a fan is turning very fast, it is not a cloud, but it appears like a cloud. In the same way, when a string is vibrating like this, then these string look like standing wave. Loops are formed, but it is not real. It is not real. So finally, I'm writing the answer and I am reading the marking scheme, reading the marking scheme, and the marking scheme is, sir, when, and read the question. The question is how standing waves are produced, how nodes and anti-nodes are created. So I am explaining, sir, when two waves traveling in opposite direction, when two waves are traveling in opposite direction of same frequency, same wavelength, but only opposite in direction. And when these waves superposed upon each other, then I think I should write in my own words. Note down beta these words. Everyone should note down and you should memorize. Or beta Manahil, you will explain me what I am saying. Okay? No, note down these sentences. When two, the question is how standing waves are produced, how nodes and anti-nodes are created in a string. Okay? This is the question. So answer is when two waves of same wavelength and frequency. And obviously, if frequency and wavelength is same, then obviously speed will also be same. So I'm not writing this word. When two waves of same wavelength and frequency are traveling in opposite direction in the same medium, in the same medium, superposed upon each other. Superposed means one wave passing over the other wave. Superposed upon each other. When two waves of same wavelength frequency traveling, wavelength and frequency are traveling in opposite direction in the same medium, superposed upon each other, nodes. I'm writing with the antinode. Antinodes, antinodes. What is antinode? Sir, antinode is points of maximum amplitude. Points of maximum amplitudes are created due to constructive interference. Due to constructive interference. And now I am writing about nodes. Nodes. Sir, what is node? I am writing the definition of node as well. Points of zero amplitude or minimum amplitude. Points of zero amplitude. Points of zero amplitudes. And these are formed, these are created due to destructive interference. Nodes are created due to destructive interference. Destructive interference. And you can read the marking scheme. So nodes, destructive interference, antinodes, constructive interference. So it is according to the marking scheme. Okay. So Manahil, finally I am repeating and I hope you can answer me. The question is how standing waves are produced. How standing waves are produced. How nodes and antinodes are created. The answer is, sir, when two waves of same wavelength and same frequency traveling in opposite direction. Traveling in opposite direction. And they are traveling in same medium. When the one wave passes over the other, it is called superposition. When the one wave passes over the other, it is called superposition. When the two waves superposed upon each other, then antinodes are created due to constructive interference, and nodes are created due to destructive interference. As well as I have explained, antinode means point of maximum amplitude, and nodes mean points of zero amplitude. जी बेटा Manahil, can you explain how standing waves are produced? Right. Manahil, हमने आपसे कहा था एक्सप्लेन करने को, आपने हमें रीड करके सुना दिया। कोई बात नहीं, लेकिन इसको याद कीजिएगा, ठीक है बेटा। हर बच्चे को ये पैराग्राफ याद, हाँ, ठीक है, ठीक है, ठीक है, ठीक है, ठीक है, कोई बात नहीं बेटा, कोई बात नहीं। हमने ऐसी मजाकन आपसे कह दिया, आप तो बिल्कुल सीरियस हो गए। अच्छा भाई, इस टॉपिक को याद करना है, इसे आप लोगों ने याद करना है, ठीक है बेटा। हर बच्चे ने ये सवाल याद करना है, अभी आप देखिएगा ये सवाल आपको बार बार नजर आएगा। अच्छा जी, now this question is completed how standing waves are produced, and now we have a mathematical question. Sorry, it is not a mathematical question, it is again a descriptive question. Sir, what is the question? The question is, the student changed the hanging weight, and you know the hanging weight produces tension in the string. In this experiment, this is hanging mass, and the weight of the hanging mass, it is producing tension. Okay, but it is producing tension. Tension in string due to the weight of hanging mass in this experiment. So the question is, during the experiment, the student is changing weight. Okay, and when weight is changing, then adjust the frequency of signal generator. Sir, what is signal generator? I will show you by a picture. This is signal generator. This device is a signal generator, and it is just like a vibrator which can produce vibration. Which can produce vibration. So this is a signal generator. Actually, until the same stationary wave was set up on the string. Sir, what does it mean? It means consider we are interested to produce one loop in the string. Okay, I am interested to keep number of loops. I have taught you this formula, n upon 2l under root t upon mu. And you know, in this question, tension is replaced by weight. In this question, the tension is replaced by weight. Okay. So if you are changing weight, okay. So we are interested, okay, when we change weight, we have to change frequency. We have to change frequency to produce same number of loop in the string. Consider in this experiment, I am interested to produce one loop each time. Okay, so same stationary wave means I am interested to produce same number of loop every time. Although I am changing the weight, I am changing the hanging load, and when I change hanging load, then number of loops are changed. Then I will adjust the frequency of signal generator to produce same number of loops. Okay. And the question is, then the student plotted a graph of f square against w. And the question is why the graph was a straight line through origin. Okay. The question is, a student changed w and he noted frequency. So the student investigating the relation between f and w, and when he note down different readings, then he plotted a graph between f square and w, and the question is the graph is a straight line passing through origin, and you have to explain why. Okay, I am going to explain, but first you should know, if a line is passing through origin and straight line, sir, what does it mean? We have studied in unit number 1. Sir, if graph is a straight line and passing through origin, it means the relation between the two physical quantities will be a straight line. So I have to show by explanation, sir, f square and w are directly proportional. And if I showed the relation between the two physical quantities directly proportional, then it is justified the graph between f square and w, it will be a straight line and passing through the origin. So it is my plan. It is my plan. And now I am going to explain my plan. Lekin before starting explanation, I have made a plan. Okay, we have to prove f square is directly proportional with weight. F square is directly proportional with weight. And sir, how is it possible? So I am going to explain. The explanation is the explanation is marking scheme starting with this equation. So I am also starting with this equation. Sir, we know, note down beta, as speed of wave is the product of frequency into wavelength. Okay, but the speed of the wave is equal to frequency into wavelength. And speed of the wave, we know it is equal to tension divided by linear density. But for this question, I am not writing tension. I am writing weight. Sir, why? Because weight producing tension. Sir, weight producing tension. So it is W is equal to frequency, and consider L is length of a string, and I think it is given in the question. Yes, it is given. It is given in the question. L is the length of the string, and if L is the length of a string, then you know for one loop, for one loop, this L is equal to lambda by 2, and this lambda is equal to 2L. We are fixing, we are fixing each time we will keep number of loop in the string only one. If the number of loop is one, if the number of loop is one, then wavelength is equal to 2L. Okay. So I am replacing this lambda by 2L. Okay. And now I am squaring both sides. Squaring both sides. And when you squaring both sides, then this square root will be eliminated. Weight divided by mu is equal to f square into 4L square. And now you know, sir, mu is a constant, length is a constant, 4 is a constant. So I am writing, sir, mu and L are constant. And if mu and L are constant, then, sir, it is clear. F square is directly proportional with W. F square is directly proportional with W. Or, or you can write, sir, if I make F square as a subject, then F square is equal to, 1 upon 4 mu L square into W. And now I am comparing with Y equal to mx plus c. Both are correct. You can write, sir, frequency is directly proportional to weight. So the graph is a straight line and passing through origin. You can write in this way. And the other way is, sir, F square along y-axis, weight along x-axis, and this is the gradient of the line. So you can say, so the graph is a straight line. If graph is a straight line, if you compare with this equation, then you can see, so the gradient is constant, and you know if gradient is constant, it means it is a straight line. If gradient is constant, then the graph is a straight line. So I am writing final answer as gradient is constant, gradient is constant. So graph of f square versus w is a straight line, and y-intercept is 0. No y-intercept. Y equal to mx plus c. No y-intercept. Okay. As y-intercept is 0, so it is passing through origin. And if you read the marking scheme, then I think it is more better. Sir, v equal to f lambda, then velocity is replaced by under root t upon mu, and then squaring both sides. And when you square on both sides and t is replaced by w, then the equation becomes as I stated. And mu and lambda are constant, or mu and L are constant. Mu and L are constant. And if you compare with this equation, y is equal to mx, it means line is passing through origin and it is a straight line. Line is passing through origin and it is a straight line. So I have explained according to the marking scheme as well as in my own style. And I am repeating, and I hope कि Zainab can say something. जैनब बेटा जरा सुनिएगा कि एग्जाम में किस तरह प्लान करेंगे। जैनब बेटा फिर आप मुझे प्लान बताइएगा। सर प्लान ये है सर, इन दिस क्वेश्चन वी हैव टू एक्सप्लेन व्हाई ग्राफ between f square and w is a straight line. We have to explain that the graph between f square against w is a straight line and it is passing through origin. Sir, for this explanation, actually I have to show that sir f square and w are directly proportional. Or we will make the equation in the form of y equal to mx. We will convert this equation in the form of y equal to mx. Okay, and yx along y-axis there is f square, along x-axis there is weight, and the gradient is constant. And if gradient is constant, then obviously the line is passing through origin, having no y-intercept. जी बेटा जैनब कुछ भी बोल दीजिए, मैं खामोशी से सुनूंगा, और आखिर में कोई मजाकन भी नहीं कहूंगा कि आपने पढ़ के सुना दिया। जो आप बोलना चाहें बेटा बोले जैनब। व्हाट इज द प्लान टू एक्सप्लेन व्हाई ग्राफ इज स्ट्रेट लाइन? सिर्फ प्लान बता दें। हम्म। 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 Gradient is constant and having no y-intercept, it means the line is passing through origin. ठीक है बेटा? Okay, okay, okay. And now I am explaining the last one. The part is describe a method that can be used to confirm that the frequency value stated on the signal generator is correct. So what does it mean? It actually you are given signal generator, and on signal generator there is a selector, and this selector we can choose any frequency of my choice. Consider if I select 50 hertz, I can select 100 hertz, I can select 150 hertz. So I can change the frequency of signal generator. Okay, and now एक्चुअली इन दिस क्वेश्चन जो कंपनी ने हमें सिलेक्टर पे नंबर लिख के दिए हैं, ठीक है जनाब, मैं उन्हें चेक करना चाहता हूं कि कंपनी ने मार्किंग सही की है या नहीं की है। कंपनी ने हमें सिलेक्टर पे नंबर लिख के दिए हुए, बट आई एम नॉट श्योर कि these numbers are correct or not correct. So I am interested to check कि whether this marking is correct or not. So the question is describe a method that can be used, and we are interested to confirm कि जो फ्रीक्वेंसी की वैल्यूज स्टेट की गई हैं वो करेक्ट है या नहीं। तो सिर्फ क्वेश्चन बेटा बनी मैं आपसे पूछना चाह रहा हूँ, ये क्वेश्चन क्योंकि काफी अजीब सा है, फिजिक्स तो बिल्कुल नहीं है इसके अंदर, ठीक है ना। क्या है कि आपको सिग्नल जनरेटर पे नंबर लिखे हुए और आपको शक है कि पता नहीं ये सही है या नहीं, तो हम आपसे क्वेश्चन कर रहे हैं कोई ऐसा मेथड बताइए ताकि वी कैन कंफर्म कि फ्रीक्वेंसी स्टेटेड ऑन द सिग्नल जनरेटर इज इट करेक्ट और नॉट करेक्ट। बनी सिर्फ सवाल समझा दे, एग्जामिनर बोलना क्या चाह रहे हैं। हम्म। ठीक है जी। जो कंपनी ने प्रिंट करके दिया हमें उसके ऊपर शक है कि पता नहीं इसने सही करके दिया नहीं सही करके दिया। ठीक है जी, तो हम उसको चेक करें सर, किससे चेक करेंगे? हाँ बोले बोले। नहीं नहीं, ड्राइंग तो नहीं बोला उसने, देखिए ना कहीं नहीं लिखा ड्राइंग, बटा उसने लिखा है डिस्क्राइब अ मेथड, कहानी सुनानी है। ठीक है बेटा। अब कैसे कहानी सुनाएंगे? तो कहानी सुनाने के लिए पहले तो मैंने कहानी को यूट्यूब पे जाके देखा, मतलब कि क्या करेंगे, तो ये कोई टीचर है और इन टीचर के पास जो है ना ये है सिग्नल जनरेटर। और फिर मैंने इनसे पूछा कि आप कैसे चेक करेंगे कि ये सही है या नहीं। तो इन्होंने मुझे टीचर ने मुझे बताया कि सर वी विल कनेक्ट दिस सिग्नल जनरेटर विद एन ऑसिलोस्कोप। ठीक है ना। एंड आई हैव टॉट योर टॉपिक सीआरओ। आई हैव टॉट योर टॉपिक सीआरओ, ओके। एंड इन सीआरओ आई टॉट यू कि वी कैन कैलकुलेट frequency of the wave display. We can calculate the time period of the given display. ठीक है जनाब। तो we will connect this signal generator with oscilloscope, and the image or the pattern formed on the screen, I can calculate the frequency of the signal generator, and then I can confirm कि whether जो उसके ऊपर उसने नंबर लिख के दिए हैं वो हमें सही दिए हैं या नहीं लिख के दिए। ठीक है जी। तो इसको तो बेटा मार्किंग स्कीम से डायरेक्टली पढ़ लो क्या बोल रहा है। और जो इसने बोला मैंने वही चीज एक्सप्लेन की है। हम लोग क्या करेंगे, सर कनेक्ट सिग्नल जनरेटर टू ऑसिलोस्कोप। ठीक है ना। कनेक्ट सिग्नल जनरेटर टू ऑसिलोस्कोप एंड नाउ मेजर टाइम पीरियड ऑफ द वेव पैटर्न। नाउ measure the time period of the wave pattern appearing on the oscilloscope, and then we can calculate frequency is equal to 1 upon time period. Okay, so this is the method which is explained by marking scheme, and I have explained कि connect signal generator to the oscilloscope, and then we will measure time period and then frequency of the pattern which is appearing on the oscilloscope. तो ये क्वेश्चन भी हमने आपको अकॉर्डिंग टू द मार्किंग स्कीम सुना दी है। एंड नाउ वी आर सॉल्विंग द लास्ट पार्ट ऑफ द मैथमेटिकल पार्ट। एंड इन दिस मैथमेटिकल पार्ट द फॉर्मूला which we have used at the top, now we are going to use it, okay? So the question is calculate mass per unit length. What is the symbol of mass per unit length? So the symbol of mass per unit length is this. This is called, this is read as mu, and mu is known as, in this question, in this topic, it is linear density. So we have to calculate linear density. Okay. And sir, how do we calculate? So, sir, we have transformed this formula, and the formula is V is equal to F lambda and then W upon under root mu. Okay. And we can use, I think, this formula. We should use this formula. Okay, beta. So note down this formula. W upon mu, W upon mu is equal to F square 4L square. Okay, you can use any form. Okay, but I'm using this one. And now we have to calculate mu. So make mu as a subject. So I'm interchanging the position of these variables. Sir, weight is 80 Newton. Sir, weight is 80 Newton. Frequency square. Sir, frequency is 659 square 4L square. Sir, L is 0.328 square. And if you solve by calculator, then the answer will be 4.3 exponent minus 4. 4.3 exponent minus 4. Okay, so you can use any form of equation, but the final answer will be 4.3 exponent minus 4. 4.3 exponent minus 4. जी बेटा, if you have noted, then I will move forward. जी बेटा, have you noted? Okay, and now, okay. जी बेटा मनाइल, हम आगे जा सकते हैं। ठीक है बेटा। And now we have another question. And in this question, a student investigated stationary unit, linear density is mass per unit length. Okay. And the unit of mass is kilogram and the unit of length is meter. So it is mass per unit length. Okay, beta. Mass is in kilogram and length is in meter. Acha ji, now the question is again, a student investigated stationary wave on a string using the apparatus shown. Okay. The frequency of the vibrator was adjusted until a stationary wave was formed with a node at each end. Here is a node and here is a node. It means it means one loop, and it is not necessary that there is one loop. Only node at each end. Okay. This was repeated for various stationary wave. It means it was repeated for various standing wave. Various means obviously sometime there will be two nodes, sometime will be three node loops, etc. So consider there are four loops. Consider. Acha ji. A meter rule was used to measure the distance d between adjacent nodes on the string. Okay, but you have a meter rule, and meter rule is placed on the bench and it is beneath the string. Okay. The question is the resolution of the meter rule was 1 millimeter. Resolution means the smallest number which you can measure by any device. It is called its resolution. Okay. So for meter rule, which we use in our daily routine, the smallest division it is zero, then it is 1 millimeter, two, three, four, five, six, seven, eight, nine, 10. And usually on the meter rule, it is 1 centimeter. And the smallest reading on the meter rule is 1 millimeter. And this 1 millimeter is called resolution of the meter rule. Okay, but the measurement were recorded to nearest 0.5 centimeter. 0.5 centimeter means 0.5 centimeter means 5 millimeter. 5 millimeter. Okay. So what does it mean? Sir, it means when the student was changing the frequency, then number of loops were changing. When number of loops were changing, then he was calculating, he was measuring the length of the one loop. And when he measured the length of one loop, his all answer like this. All answer like this. The length of one loop, consider it is 15 millimeter. Consider it was 20 millimeter. It was 25 millimeter. It was 30 millimeter. So you can see all the readings are nearest to 5 millimeter. Nothing reading is 16 millimeter or 22 millimeter or 29 millimeter or 33 millimeter. It means, I think, it is my suggestion. It means the student is not able to measure 1 millimeter. Actually, he is measuring all the lengths either 5 millimeter, then 10 millimeter, then 15 millimeter, then 20 millimeter. वो रीडिंग जितनी भी ले रहा है वो सारी सारी की सारी 5 के मल्टीपल में उसको नजर आ रही है रीडिंग्स। ठीक है जनाब, जबकि स्केल की जो रेजोल्यूशन है वो 1 मिलीमीटर है। तो देखिए जब कभी किसी क्वेश्चन में लफ्ज आ जाए ना सजेस्ट, तो सजेस्ट का मतलब होता है कि वी आर सजेस्टिंग एंड माई सजेशन मे नॉट बी अकॉर्डिंग टू द साइंटिफिक रूल। हमने कोई आम जिंदगी की बात कर लेनी है कि उससे ये गलती हो रही होगी, इसलिए उसकी सारी रीडिंग्स जो है ना वो 5 मिलीमीटर की रेजोल्यूशन में आ रही है, 1 मिलीमीटर की रेजोल्यूशन में उसको नहीं आ रही। ठीक है जनाब। तो इसका सजेशन मेरे ख्याल में ये है, क्योंकि मैंने फिजिक्स में बच्चों को लैब में ये एक्सपेरिमेंट कराए हैं, और जब एक्सपेरिमेंट कराते हैं ना तो गौर से सुनिएगा। सर ये जो नोड आप लोग बना रहे होते हैं ना टीचर, थ्योरी पढ़ाते वक्त जब हम लोग नोड बना रहे होते हैं तो बड़े मजे से बनाते हैं नोड ये रहा, but practically when you are in lab and if you are making stationary waves, then this loop, sorry, then node is not just a dot. ठीक है जनाब, जो नोड होता है ना वो एक डॉट की तरह नहीं बना हुआ नजर आ रहा होता, वो काफी लंबा खिंचा हुआ नजर आ रहा होता है, समझ में ही नहीं आता कि नोड है कौन सा। और जब नोड उसको समझ में नहीं आ रहा, नजर ही नहीं आ रहा उसको सही से, तो ऑब्वियसली उसकी जो रीडिंग्स है वो 1 मिलीमीटर की रेजोल्यूशन में नहीं आ रही, बल्कि वो 5 मिलीमीटर की रेजोल्यूशन में आ रही है। ठीक है जनाब, तो माई सजेशन इज एंड इट शुड बी अकॉर्डिंग टू मार्किंग स्कीम। सर मार्किंग स्कीम सजेशन इज, सर इट इज वेरी डिफिकल्ट टू जज द एग्जैक्ट पोजीशन ऑफ नोड। ठीक है जनाब, इट इज वेरी डिफिकल्ट टू जज द एग्जैक्ट पोजीशन ऑफ नोड, एंड यू नो ruler is not close to the string. String is above the ruler, and there is a gap between ruler and a string. There is a gap. Okay. So if there is a gap, then there will be parallax error as well. Sir, what is parallax error? Why parallax error? You know कि अगर आप wall clock देख रहे हो which is not digital, विच इज नॉट डिजिटल, उसके ऊपर अगर वो नीडल्स वाली अगर वॉल क्लॉक देख रहे हो, तो इफ यू चेंज योर पोजीशन, इफ यू चेंज योर पोजीशन ऑफ एंगल ऑफ विजन, एंगल ऑफ साइट, देन यू विल फाइंड डिफरेंट टाइमिंग्स, ऑल्दो देयर विल बी टाइम की यूनिक वैल्यू होगी, बट इफ यू आर चेंजिंग योर पोजीशन, then you will find different position of pointer on the wall clock. In the same way, on the same way, if the ruler is at a quite large distance from the string, then obviously there is parallax error. So this is my suggestion. And suggestion number one, I think it is best. So it is very difficult to judge the exact position of node. That is why the student is not able to note down the accurate readings. And accurate readings means the reading should be around in 1 millimeter resolution, but the readings are in 5 millimeter resolution. ठीक है जी। तो बेटा बनीन, आप अपने अल्फाज में मुझे बताएंगी कि स्टूडेंट से क्या गलती हो रही है, मुझे कोई भी मशवरा दे दीजिए, कोई भी। जी बेटा बनीन, रीडिंग उसकी स्टूडेंट की इतनी अच्छी क्यों नहीं आ रही स्टैंडिंग वेव में? सर नोड इतने शार्प नजर आते ही नहीं है जैसा कि पढ़ाते वक्त नजर आ रहे होते हैं, बट प्रैक्टिकली नोड्स आर नॉट सच sharp nodes, so it is very difficult to judge the position of node, so you cannot easily measure, you cannot measure accurately the length of each loop, so it is the problem. अच्छा जी, now we have a graph. जी बेटा बनीन बोलिए। ओके ओके, आई एम एंडिंग माई क्लास एज वेल। ओके बेटा, ओके, अल्लाह हाफिज।